Lesson 1-6 is equations of proportional relationships. Now today, you're going to write equations to represent proportional relationships. So we can write these equations from graphs, and we can write them from a word problem. Now, a linear relationship is proportional when the ratio of y to x is a constant k. Okay, what that means, proportional. What that means is when there is the fractions are equivalent for every y over x. So it's always going to be y to x. Okay, so the ratio is always going to be y to x, and that is going to be our constant k. So this is what the equation looks like over here. So y is equal to kx, where the k is not ever going to be equal to 0. It always has to be either a positive number or a negative number, but it cannot be 0. Okay? Now remember, when we did our graphs, we had the unit rate, the constant of proportionality, we called it the C of P, the constant of proportionality, is also when, it's always when x is equal to 1. In other words, it is at the unit rate. Okay, so it's at a unit rate. Okay, so in this example, if we're looking at the unit rate or the constant of proportionality, there's 1, right? And then we go up to the graph, and this number here is 3. So the constant of proportionality is 3 over 1. You see, this is the y value over here. This is the x value over here. And if I do y over x, that's going to be 3 over 1. So the constant of proportionality, or the k, is equal to 3. So when you look at the equation, look at where k goes. K goes right there. So the equation is always going to be y is equal to kx. Y is equal to kx, where the constant of proportionality is your k. All right? So that is where we're going to get our equation, y is equal to 3x. And there's our equation right there. So in other words, you can use the constant of proportionality, or the unit rate, to write an equation in the form y equals kx that represents a proportional relationship. Make sure you write that down. Actually, make sure you write all of that down. So for example 1, we want to identify the constant of proportionality in equations. So it says an airplane travels 780 miles in 4 hours. So write down the important information. 780 miles in 4 hours. They've already written the equation. We want to look for the constant of proportionality, okay? So the equation is y is equal to 195x. That models the situation. Now, the k, remember, it's y is equal to kx. The k is a constant of proportionality. Y is equal to kx. Okay? And so the k is the constant of proportionality. So here we can say constant of proportionality is 195. So k is equal to 195. Now, how did you get that? Well, it's a unit rate. So here, if we have 780 miles, if we're comparing miles to hours, this is 780 miles over 4 hours. If we simplify that, if we want the denominator to be 1, we're going to divide by 4 down here, and we're going to divide by 4 up there. So here, if I divide 780 780 divided by 4, that's going to give me 195. So that's 195 miles in 1 hour. Now, when you find your unit rate, that is what's going to help you describe what the constant of proportionality represents. So part B says, what does the constant of proportionality represent in the context of the problem? Well, it means that the airplane is traveling 195 miles in 1 hour. That's what it means. All right, make sure you write that down. All right, example 2 is proportional relationships and equations. So it says a mechanic charges $270 for 5 hours of work on a car. We want to write an equation that compares the total cost to the number of hours that he works on the car if it is a proportional relationship. Okay, so here this is telling us it's proportional, right? The ratio is $270 for 5 hours. Okay, now we want to write an equation that compares the total cost to the number of hours he works. So remember the equation, and it's always going to be the same. It's going to be y is equal to kx. Please make sure you're writing all of this highlighted information down. It's very important. So now we are comparing the total cost to the number of hours. So the first part, part A, is to find the constant of proportionality. And then remember, that means we want to find the unit rate. So the ratio is dollars to hours. So that's dollars to hours. So this is equal to $270 for 5 hours of work. Now to change that to a unit rate, we want to divide by the denominator. So we want 1 in the denominator, so 5 divided by 5 is equal to 1. And if I divide by 5 in the denominator, I have to divide by 5 in the numerator. So we have 1 hour in the denominator, and then 270 divided by 5 is equal to 54. So what that means is that what the constant of proportionality means is that he earns $54 for every 1 hour of work that he does. So this constant of proportionality is what we are going to put into the equation. So again, the equation is y equals kx. And that constant of proportionality, I'm going to just write it here. This is the constant of proportionality. That is the value k. This is equal to the k. So we just have to put 54 in there for k. And that's it. So my equation is y is equal to 54x. All right, so for example 3, we want to write an equation from a table. So it says here, the table shows the proportional relationship between the number of gallons used and the number of miles driven. So we know that this is a proportional relationship, okay? And what we are comparing is the number of gallons used and the number of miles driven, okay? So what we want to do is we want to write an equation, y equals kx, don't forget, relating the number of gallons used, x, and the number of miles driven, y. Now, let me just go back here. If you look at the problem, it says gallons over miles and gallons over miles. But remember, our k is equal to y over x, right? So if I'm looking at y over x, let's look at what these are. Let's see. We want to write an equation relating the number of gallons used, that's our x. Does everybody see that? That's the x. And and highlight in a different color. And the number of miles driven, that's the y. So when we do y over x, it's going to be miles over gallons, okay? It doesn't always go in the order that it says it in the problem, okay? So we're comparing y over x. This is going to give us our k. Move this over. That's going to give us our k. So k is equal to y over x. Y is the number of miles driven over x, which is the number of gallons, okay? So when we are looking at our table, we have miles in the bottom row and we have gallons in the top row. Now, because it says that the relationship is proportional, that tells me that all of these ratios are going to be equal. And we'll check that, okay? So miles, let's just start with this first one, okay? Start with that first ratio. Miles is on the bottom, so on the second row. So this is going to be miles on top, that's 160, over gallons, 5. So if I want to change this to a unit rate, we divide by the denominator, in the numerator and the denominator, and we get 160 divided by 5, that equals 32. So this is going to be 32 miles in the numerator and 1 gallon in the denominator. So that means that that this person drives 32 miles on 1 gallon of gas, okay? Now, before we write our equation, let's just double check all the other ratios. Okay, so I just want to show you. If we do 320 divided by 10, of course, that's going to give us 32 miles in 1 gallon. If I divide 480 divided by 15, that gives us 32, and 640 divided by 20, that gives us 32. So you can see they are all equivalent, okay? So this is our constant of proportionality. This is our constant of proportionality, our CFP. Now, this is our K. And so that is what's going to go into our equation. And our equation is going to be y is equal to kx. So the equation is y is equal to 32x. All right, so for example 4, we're going to write the equation from the graph. So it says, Philip is selling fresh zucchini from his garden. The graph shows the relationship between the number of zucchini sold and the amount of money Philip earned. We want to write an equation relating the number of zucchini sold. Let's highlight it. So we're writing an equation relating the number of zucchini sold, that's our x, and the amount of money earned. So the amount of money earned, that is our y. And remember, our equation, our constant of proportionality is y over x, okay? So we want to write an equation. Now, before we write the equation, we need to, part A, determine the constant of proportionality. So our k is going to be equal to the y over x, okay? Now, when I look at my graph, you can use any point on this graph, okay? Because we know, because it is a straight line and it goes through the origin, we know this is a proportional relationship, okay? So we're going to go from any point. Let's do 10. Let's do 10. So we're going to use that as our x. We're going to go up to our graph, and this is our y. Okay? So 10 is our x, and 15 is our y. Okay? So when we put this into our formula here, we have y is equal to the amount of money earned, so that's $15, And then the x is the number of zucchini. So this is going to be 10 zucchini. I'll put Z-U-C. Okay, so this is $15 for 10 zucchini. Now, we want to change that to a unit rate. So what are we going to divide by in the numerator and the denominator? 10. Yeah, so we divide by 10. So when we divide by 10, we have 15 divided by 10, and that's going to give us 1.5. So that 1.5, that means $1.50. Don't forget, it's $1.50. Now let me change that to a, oops, let me change that. Because this is what you got in a calculator. So this is what you get in a calculator. And then when you write it, it means $1.50, okay? So we've got $1.50 for 1 zucchini. That's what that means, okay? And then again, if you want to check on the calculator, if you check the other points, let's see, this is going to be 15 over 2250. So 2250 divided by 15, that gives me $1.50. This one up here, that's 30 over 20, so that's 30 divided by 20, and that gives you $1.50. So it is all going to be the same. Now this is our constant of proportionality. This is our constant of proportionality, and that's what we're going to put in our equation, okay? So when we write the equation, and again, y is equal to kx, where k is the constant of proportionality. K is the constant of proportionality. That 1.5 goes in here. Now, when I write it in the equation, I don't have to write $1.50, okay? You can go ahead and write y is equal to 1.5x, and there's your equation. Please make sure you upload your notes to Focus.